Hope you all are fit and fine at your place. We have already discussed about pressure, what are the variations of pressure and pressure exerted by liquids and gases. Now let's start with the next topic of chapter, that is atmospheric pressure. It is clear from the name, that is pressure exerted by atmosphere, that is atmospheric pressure. As you know, the atmosphere of the earth has its own weight. Why it is having weight? Because of some gases present in the air. Right? In the atmosphere, the gases are present and they gases combine and they are having some weight. And that atmosphere is exerting pressure on the surface of earth. So, atmospheric pressure, we can define atmospheric pressure as the pressure exerted on any object by the weight of the air above it, that is known as atmospheric pressure. Let's understand with the help of example. I think everyone has seen a rubber sucker. Okay, what rubber sucker do? Here I am drawing. This is a plane surface and this is a rubber sucker. Fine. This rubber sucker like this. Now, whenever you just put this rubber sucker on the surface of this plane, right? What will happen? The air inside it when you press it, it will go outward, right? Now, what is happening? Why it is held on the surface only? Because the pressure is exerted, the pressure from the air is exerted on the rubber sucker, and it helps to hold the rubber sucker on the plane, right? So in this way, from here you can see that the pressure is being applied on the rubber sucker. That is why it is held on a plane. Plane may be any kind of glass, any kind of window. That rubber sucker, it just stick, right? If I want to just remove the rubber sucker from the surface, what I have to do? I have to apply pressure, because atmospheric pressure is applying in this direction, and if I want to pull it, I have to apply the pressure in opposite direction but with more force. It means I have to apply more force. Right, to just pull the rubber sucker, right? So this is due to the rubber sucker that is one example of it. There are so many examples. It means the atmosphere is exerting the pressure on each and every object on the earth surface. You can also understand this atmospheric pressure with the help of this activity.
Atmospheric pressure is the pressure exerted by the atmosphere of Earth. The envelope of gases surrounding the Earth or any other planet is called atmosphere. It extends up to 800 kilometers above the Earth. An air pressure of 9.8 Newton unit square centimeter is exerted on our body. But we do not collapse because there is air pressure present within us. The force within us balances the force pushing us from outside. The pressure inside our body is roughly the same as the pressure outside, so there is no net pressure on us. Atmospheric pressure can be measured using a barometer. It is mainly used in meteorology. The bar is a metric unit of pressure. It is exactly equal to 1 lakh Pascal. It is approximately equal to the atmospheric pressure on Earth at sea level. Now, let us perform some experiments on air pressure. Take two identical plastic bottles, A and B. Fill cold water in bottle A and hot water in bottle B. Put the lids on the bottles and keep them undisturbed for some time. Next, remove the bottle caps and pour the water down the drain. Put back the lids of the bottles. Next, place both the bottles inside the refrigerator for 5 minutes. What do you observe? Nothing happens to bottle A, but bottle B gets crushed. The air inside bottle B expands due to the hot water. When the bottle is placed inside the refrigerator, the sudden cooling creates a partial vacuum. The extremely low pressure of the partial vacuum inside the forces the higher pressure of the air outside the can to crush it. This experiment thus proves that air has pressure. To perform this experiment, you will require 2 straws, a glass soda bottle, some water, and some clay. Fill half the soda bottle with water. Put 2 straws in the bottle so that the ends are under the surface of the water. Seal the mouth of the bottle with clay to prevent air from entering inside the bottle. Next, try to sip some water through one straw with the second one left open. Now again try to sip water, but this time close the second straw by keeping a finger pressed over it. In the first case, when you sip water, the atmospheric pressure becomes lower. It pushes the surface of the water. Since pressure is transmitted equally in all directions, it will push the water up the straw and into the mouth. In the second case, when you try to sip water with the second straw covered, it does not allow the atmosphere to push down on the surface of the water. Thus, water does not move up into the straw. This experiment proves that air has pressure. For this experiment, you will require 2 different colored straws, a glass of water, and a pin. First, using a yellow straw, drink water from the glass. Next, with the help of a pin, make 1 or 2 holes in the blue straw. Try sipping water from the glass using this straw. When you sip water using the yellow straw, the air pressure inside the straw is reduced. As the air pressure outside the straw is higher, it pushes down on the water and in the process forces some of the liquid up the straw. But the blue straw with the holes allows an endless supply of air to come in. And therefore, the air pressure is never reduced and the liquid never travels up the straw. This experiment also proves that air has pressure.
Now, we will study about the variation of atmospheric pressure with altitude. Firstly, the first term you have to learn that what altitude means. Altitude means the height of the place above sea level. Above sea level, whatever the height is, that is known as altitude. Now, what is the effect of altitude on the atmospheric pressure? With increase in altitude, or you can say that with increase in height above the sea level, the atmospheric pressure decreases. Why it is so? As atmospheric pressure what it is. It is the pressure exerted by the air present on it. So we are having the different layers of air. Suppose this is above the, I am drawing above the sea level. Now, as you know, the height increases like this. Fine. If the person is at this, okay, then too many layers of air are above it. Fine. Too many layers are there. Fine. It means its weight is very high. it means the atmospheric pressure is also very high. Whenever the altitude increases, means the person is now moving this. It has moved at this height. It means now the layers of air are less as comparison to this. If the layers of air are less, it means the pressure exerted by that air of layers is also less. From here, what I will conclude, that whenever the altitude increases, the atmospheric pressure decreases, because the amount of air, the layers of air present, as height increases, it also decreases. Fine. So, if there is a sudden change in the atmospheric pressure, what happened to our body? If there is a sudden change, if you observe in an aeroplane, then you will observe that you are not able to hear properly. Fine, there is some different kind of sound in your ear. Why this has happened? So because the atmospheric pressure at the height is less, at altitude it is less. That is the effect of altitude. When the altitude is increased, atmospheric pressure is decreased. If there is a sudden change, right? If we are at least and suddenly you just go up, then atmospheric pressure decreases. There are also so many examples where you can see the effect of altitude on the atmospheric pressure. Example, that is the example of elevator. Whenever you just go in elevator, whenever this goes up, you feel just some discomfort. Why? Because the atmospheric pressure decreases and you feel discomfort. This is all about the atmospheric pressure and the variation of atmospheric pressure with altitude.